The MITS Altair 8800 is a microcomputer designed in 1974 based on the Intel 8080 CPU. Interest grew quickly after it was featured on the cover of the January 1975 issue of Popular Electronics, and was sold by mail order through advertisements there, in Radio Electronics, and in other hobbyist magazines. The designers hoped to sell a few hundred build-it-yourself kits to hobbyists, and were surprised when they sold thousands in the first month. The Altair also appealed to individuals and businesses that just wanted a computer and purchased the assembled version. The Altair is widely recognized as the spark that ignited the microcomputer revolution. The computer bus designed for the Altair was to become a de facto standard in the form of the S100 bus, and the first programming language for the machine was Microsoft's founding product, Altair BASIC. History. While serving at the Air Force Weapons Laboratory at Kirtland Air Force Base, Ed Roberts and Forrest M. Mims III decided to use their electronics background to produce small kits for model rocket hobbyists. In 1969, Roberts and Mims, along with Stan Cagle and Robert Zoller, founded Micro-Instrumentation and Telemetry Systems in Roberts' garage in Albuquerque, New Mexico, and started selling radio transmitters and instruments for model rockets. Calculators equals, the model rocket kits were a modest success and MITS wanted to try a kit that would appeal to more hobbyists. The November 1970 issue of Popular Electronics featured the Opticom, a kit from MITS that would send voice over an LED light beam. Mims and Cagle were losing interest in the kit business, so Roberts bought his partners out, then began developing a calculator kit. Electronic Arrays had just announced a set of 6 LSI integrated circuit chips that would make a 4-function calculator. The MITS 816 calculator kit used the chipset and was featured on the November 1971 cover of Popular Electronics. This calculator kit sold for $175. Forrest Mims wrote the assembly manual for this kit and many others over the next several years. He often accepted a copy of the kit as payment. The calculator was successful and was followed by several improved models. The MITS 1440 calculator was featured in the July 1973 issues of Radio Electronics. It had a 14-digit display, memory, and square root. The kit sold for $200 and the assembled version was $250. MITS later developed a programmer unit that would connect to the 816 or 1440 calculator and allow programs of up to 256 steps. Test equipment equals, in addition to calculators, MITS made a line of test equipment kits. These included an IC tester, a waveform generator, a digital voltmeter, and several other instruments. To keep up with the demand, MITS moved into a larger building at 6328 Lineni in Albuquerque in 1973. They installed a wave soldering machine and an assembly line at the new location. In 1972, Texas Instruments developed its own calculator chip and started selling complete calculators at less than half the price of other commercial models. MITS and many other companies were devastated by this, and Roberts struggled to reduce his $250,000 debt. Popular Electronics equals. In January 1972, Popular Electronics merged with another Ziff Davis magazine, Electronics World. The change in editorial staff upset many of their authors, and they started writing for a competing magazine, Radio Electronics. In 1972 and 1973, some of the best construction projects appeared in Radio Electronics. In 1974, Art Salzberg became editor of Popular Electronics. It was Salzberg's goal to reclaim the lead in electronics projects. He was impressed with Don Lancaster's TV typewriter article and wanted computer projects for Popular Electronics. Don Lancaster did an ASCII keyboard for Popular Electronics in April 1974. They were evaluating a computer trainer project by Jerry Ogden when the Mark 8 8008-based computer by Jonathan Titus appeared on the July 1974 cover of Radio Electronics. The computer trainer was put on hold and the editors looked for a real computer system. One of the editors, Les Solomon, knew MITS was working on an Intel 8080-based computer project and thought Roberts could provide the project for the always popular January issue. The TV typewriter and the Mark 8 computer projects were just a detailed set of plans and a set of bare printed circuit boards. The hobbyist faced the daunting task of acquiring all of the integrated circuits and other components. The editors of Popular Electronics wanted a complete kit in a professional-looking enclosure. The typical MITS product had a generic name like the Model 1440 calculator, or the Model 1600 digital voltmeter. Ed Roberts was busy finishing the design and left the naming of the computer to the editors of Popular Electronics. One explanation of the Altair name, which editor Les Solomon later told the audience at the first Altair computer convention, is that the name was inspired by Les's 12-year-old daughter, Lauren. She said, "Why don't you call it Altair? That's where the Enterprise is going tonight." The Star Trek episode is probably a mock time, as this is the only one from the original series which takes the Enterprise crew to Altair. A more probable version is that the Altair was originally going to be named the PE-8, but Les Solomon thought this name to be rather dull, so Les, Alexander Berrower, and John McVeigh decided that, "It's a stellar event, so let's name it after a star." McVeigh suggested Altair, the 12th brightest star in the sky. Ed Roberts and Bill Yates finished the first prototype in October 1974 and shipped it to Popular Electronics in New York via the Railway Express Agency. However, it never arrived due to a strike by the shipping company. Solomon already had a number of pictures of the machine and the article was based on them. Roberts got to work on building a replacement. The computer on the magazine cover is an empty box with just switches and LEDs on the front panel. The finished Altair computer had a completely different circuit board layout than the prototype shown in the magazine. The January 1975 issues appeared on newsstands a week before Christmas of 1974 and the kit was officially available for sale. Intel 8080 Ed Roberts had designed and manufactured programmable calculators and was familiar with the microprocessors available in 1974. The Intel 4004 and Intel 8008 were not powerful enough. The National Semiconductor IMP8 and IMP16 required external hardware, and the Motorola 6800 was still in development, so he chose the 8-bit Intel 8080. At that time, Intel's main business was selling memory chips by the thousands to computer companies. They had no experience in selling small quantities of microprocessors. When the 8080 was introduced in April 1974, Intel set the single unit price at $360. That figure had a nice ring to it, recalled Intel's Dave House in 1984. Besides, it was a computer, and they usually cost thousands of dollars, so we felt it was a reasonable price. Ed Roberts had experience in buying OEM quantities of calculator chips and he was able to negotiate a $75 price for the 8080 microprocessor chips. Intel made the Intellect 8 microprocessor development system that typically sold for a very profitable $10,000. It was functionally similar to the Altair 8800 but it was a commercial-grade system with a wide selection of peripherals and development software. Customers would ask Intel why their Intellect 8 was so expensive when that Altair was only $400. Some salesmen said that MITS was getting cosmetic rejects or otherwise inferior chips. In July 1975, Intel sent a letter to its sales force stating that the MITS Altair 8800 computer used standard Intel 8080 parts. The sales force should sell the Intellect system based on its merits and that no one should make derogatory comments about valued customers like MITS. The letter was reprinted in the August 1975 issue of MITS Computer Notes. The cosmetic defect rumor has appeared in many accounts over the years although both MITS and Intel issued written denials in 1975. The launch. For a decade, colleges had required science and engineering majors to take a course in computer programming, typically using the Fortran or BASIC languages. This meant there was a sizable customer base who knew about computers. In 1970, electronic calculators were not seen outside of a laboratory, but by 1974 they were a common household item. calculators and video games like Pong introduced computer power to the general public. Electronics hobbyists were moving on to digital projects such as digital voltmeters and frequency counters. There were Intel 8008-based computer systems available in 1974, but they were not powerful enough to run a high-level language like BASIC. The Altair had enough power to be actually useful, and was designed as an expandable system that opened it up to all sorts of applications. Ed Roberts optimistically told his banker that he could sell 800 computers, while in reality they needed to sell 200 over the next year just to break even. When readers got the January issue of Popular Electronics, MITS was flooded with inquiries and orders. They had to hire extra people just to answer the phones. In February, MITS received 1,000 orders for the Altair 8800. The quoted delivery time was 60 days, but it was months before they could meet that. Roberts focused on delivering the computer. All of the options would wait until they could keep pace with the orders. MITS claimed to have delivered 2,500 Altair 8800s by the end of May. The number was over 5,000 by August 1975. MITS had under 20 employees in January but had grown to 90 by October 1975. The Altair 8800 computer was a break-even sale for MITS. They needed to sell additional memory boards, I/O boards and other options to make a profit. The system came with a 1024-word memory board populated with 256 bytes. The BASIC language was announced in July 1975 and it required one or two 4096-word memory boards and an interface board. MITS price list, Popular Electronics, August 1975. 4K Basic Language $60, 8K Basic Language $75, MITS had no competition for the first half of 1975. Their 4K memory board used dynamic RAM and it had several design problems. The delay in shipping optional boards and the problems with the 4K memory board created an opportunity for outside suppliers. An enterprising Altair owner, Robert Marsh, designed a 4K static memory that was plug-in compatible with the Altair 8800 and sold for $255. His company was Processor Technology, one of the most successful Altair-compatible board suppliers. Their advertisement in the July 1975 issue of Popular Electronics promised interface and PROM boards in addition to the 4K memory board. They would later develop a popular video display board that would plug directly into the Altair. A consulting company in San Leandro, California, IMS Associates Incorporated, wanted to purchase several Altair computers, but the long delivery time convinced them that they should build their own computers. In the October 1975 Popular Electronics, a small advertisement announced the IMS AI-8080 computer. The ad noted that all boards were plug-compatible with the Altair 8800. The computer cost $439 for a kit. The first 50 IMS AI computers shipped in December 1975. The IMS AI-8080 computer improved on the original Altair design in several areas. It was easier to assemble. The Altair required 60 wire connections between the front panel and the motherboard. The IMS AI motherboard had 18 slots. The MITS motherboard consisted of 4 slot segments that had to be connected together with 100 wires. The IMS AI also had a larger power supply to handle the increasing number of expansion boards used in typical systems. The IMS AI advantage was short-lived because MITS had recognized these shortcomings and developed the Altair 8800B, which was introduced in June 1976. In 1977, PERT Computer Corporation purchased MITS and began to market the computer, without changes, as the PCC 8800 in 1978. Description: in the first design of the Altair, the parts needed to make a complete machine would not fit on a single motherboard, and the machine consisted of 4 boards stacked on top of each other with standoffs. Another problem facing Roberts was that the parts needed to make a truly useful computer weren't available, or wouldn't be designed in time for the January launch date. So during the construction of the second model, he decided to build most of the machine on removable cards, reducing the motherboard to nothing more than an interconnect between the cards, a backplane. The The BASIC machine consisted of 5 cards, including the CPU on one and memory on another. He then looked for a cheap source of connectors, and came across a supply of 100-pin edge connectors. The S100 bus was eventually acknowledged by the professional computer community and adopted as the IEEE 696 computer bus standard. The Altair bus consists of the pins of the Intel 8080 run out onto the backplane. No particular level of thought went into the design, which led to such disasters as shorting from various power lines of differing voltages being located next to each other. Another oddity was that the system included 2 unidirectional 8-bit data buses, but only a single bidirectional 16-bit address bus. A deal on power supplies led to the use of +8V and +18V, which had to be locally regulated on the cards to TTL or RS-232 standard voltage levels. The Altair shipped in a 2-piece case. The backplane and power supply were mounted on a base plate, along with the front and rear of the box. The lid was shaped like a C, forming the top, left and right sides of the box. The front panel, which was inspired by the Data General Nova mini computer, included a large number of toggle switches to feed binary data directly into the memory of the machine, and a number of red LEDs to read those values back out. Programming the Altair was an extremely tedious process. The user toggled the switches to positions corresponding to the desired 8080 microprocessor instruction or opcode in binary, then used the deposit next switch to load that instruction into the next address of the machine's memory. They repeated this step until all the opcodes of a presumably complete and correct program were in place. When the machine first shipped, flipping switches on the front panel was the only way to get programs or data into the machine, and the only output from the programs was the patterns of lights on the panel. Nevertheless, many were sold in this form. Roberts was already hard at work on additional cards, including a paper tape reader for storage, additional RAM cards, and a RS-232 interface to connect to a proper teletype terminal. In 2013 an Altair 8800 clone was introduced for enthusiasts who wanted to recreate the Altair 8800 experience, but with modern hardware. The clone carried the same price as the original Altair 8800. Software Altair BASIC Roberts received a letter from Trafo Data asking if he would be interested in buying its BASIC programming language for the machine. He called the company and reached a private home, where no one had heard of anything like BASIC. In fact, the letter had been sent by Bill Gates and Paul Allen from the Boston area, and they had no BASIC yet to offer. When they called Roberts to follow up on the letter, he expressed his interest, and the two started work on their BASIC interpreter using a self-made simulator for the 8080 on a PDP-10 mini computer. They figured they had 30 days before someone else beat them to the punch, and once they had a version working on the simulator, Allen flew to Albuquerque to deliver the program, Altair BASIC, on a paper tape. The first time it was run, it displayed ready. Then Allen typed print 2 + 2, and it immediately printed the correct answer, 4. The game Lunar Lander was entered in and this worked as well. Gates soon joined Allen and formed Microsoft, then spelled Microsoft. See also, SIMH emulates Altair 8800 with both 8080 and Z80. IMSAI 8080. References. Further reading. Books Solomon, Les. Solomon's Memory. In Ditlier, Steve. Digital Delhi, The Comprehensive, User-Lovable Menu of Computer Lore, Culture, Lifestyles and Fancy. Workman Publishing. ISBN 0-89480-591-6. Freiberger, Paul. Swain, Michael. Fire in the Valley, The Making of the Personal Computer. New York, McGraw-Hill. ISBN 0-07-135892-7. Mims, Forrest M. Siller Connections, Coming of Age in the Electronic Era. New York, McGraw-Hill. ISBN 978-0-07-042411-1. Veit, Stanley. Stan Veit's History of the Personal Computer. Asheville, North Carolina, WorldCom. ISBN 978-1-56664-030-5. Young, Jeffrey S. Forbes Greatest Technology Stories, Inspiring Tales of the Entrepreneurs. New York, John Wiley & Sons. ISBN 0-471-24374-4. Chapter 6 Mechanics, Kits and Microcomputers. Magazines Grealish, David. Ed Roberts interview with Historically Brewed magazine. Historically Brewed. Retrieved November 22, 2007. Green, Wayne. From the publisher Are They Real? Byte 1, pages 61, 81, 87. CS1 Maintenance, Extra Text, MIMS, Forrest and the Altair Story. Early Days at MITS. Creative Computing 10, pages 17. Archived from the original on April 8, 2007. Retrieved March 17, 2007. CS1 Maintenance, Extra Text, MIMS, Forrest. The 10th anniversary of the Altair 8800 inches. Computers and Electronics 23, pages 58-62, 81-82. CS1 Maintenance, Extra Text, Roberts, H. Edward. William Yates. Altair 8800 Mini Computer. Popular Electronics 7, pages 33-38. Retrieved April 26, 2008. CS1 Maintenance, Extra Text. External links, Altair 8800. New Mexico Museum of Natural History and Science. Retrieved December 18, 2007. MITS Altair 8800 exhibit at old-computers.com's Virtual Computer Museum, Virtual Altair Museum, Altair 8800 images and information at vintage-computer.com, Marcus Bennett's Altair documentation resource, www.bellcomputers.com maker of a hardware emulation of the 8800 running on an Admiral AVR 8515, http, altairclone.com.